Inside silicon, the technology behind everything.
We all use AI now, right? But have you ever really stopped to think about what's physically happening when you type in a prompt? It feels like pure magic, but it's not. Today, we're going to pull back the curtain and look at the massive physical infrastructure that AI actually runs on. Think about it. When you ask ChatGPT a question, you're not just talking to some software in the cloud. You are literally triggering a physical chain reaction. Thousands of hyper-advanced silicon chips are firing up inside these enormous data centers, and they're eating up just an incredible amount of power to get you that answer. And let's be honest, the experience is magical, isn't it? It feels so seamless. You ask a question, and boom, you get an answer. But here's the thing, it's not magic. Every single word that comes back to you, that's the end product of some really specific hardware decisions, hard physical limits in manufacturing, and just the brutal economics of making computer chips. So that leads us to the big question for today. What physical hardware is actually running your AI query? We're going to peel back the layers and see what's really inside. All right, so let's start at the heart of it all, the engine. And for AI, this engine, well, it's not the kind of chip you have in your laptop. Nope. It needs something totally different, a special kind of chip built for a very specific job. Okay, to really get this, you have to understand the difference between two types of chips. Think of your computer's main chip, the CPU, as a brilliant strategist. It's fantastic at handling really complex problems, but it does them one at a time, sequentially. But you see, an AI model doesn't need a strategist. It needs a massive army. And that's where the GPU, the graphics processing unit, comes in. A GPU is that army. It's built to do thousands and thousands of pretty simple math problems all at the exact same time. And that massive parallel processing, that's the secret sauce. It's exactly what these AI models are built on. In the actual chips powering something like ChatGPT, they're these total workhorses. We're talking about specialized data center GPUs. You've probably heard of them. NVIDIA's A100, and its even more powerful successor, the H100. And just to be clear, these are not the same thing you put in your gaming PC. These are pure, purpose-built computational monsters. And to give you an idea of just how insane these things are, a single H100 GPU has over 80 billion transistors packed onto it. I mean, each one of those is built with almost atomic-level precision. That is a mind-boggling amount of power packed into a piece of silicon smaller than your hand. Okay, but here's the catch. Having a ridiculously powerful engine is totally useless if you can't get fuel to it fast enough, right? And that brings us to the next critical part of this puzzle. And frankly, it's often the real bottleneck: memory. You see, these GPUs don't just use the regular RAM sticks you'd find in a PC. They need something special called high bandwidth memory, or HBM. And HBM isn't just faster, it's built completely differently. The memory chips are literally stacked on top of each other in 3D and then placed right next to the GPU itself. This whole setup creates this massive, super wide data highway, all designed to just shovel data into that engine. So just how wide is that highway? Get this. An NVIDIA H100 can pull data from its memory at over 3 terabytes per second. That is an insane speed. And you need that speed. It's the only way to keep all 80 billion of those transistors busy, constantly feeding them the data and the numbers that actually make up the AI model itself. So here's the key takeaway, really. Everyone talks about the GPU. It gets all the glory. But this HBM, it's the real unsung hero. And it's also the biggest challenge. It is incredibly expensive, it's super hard to make successfully, and a lot of the time it's the amount of this special memory you can get, not the raw power of the GPU. That's the real bottleneck. It's what's holding back AI performance. All right, so we've got the engine, the GPU, and we've got the fuel line, the HBM. But where does this stuff actually get made? I mean, who is the factory behind this whole AI revolution? Now, most of us know that NVIDIA designs these amazing AI chips, right? They're the architects. They drop the blueprints for things like the A100 and the H100. But here's the twist. It's a twist that basically the entire modern tech world is built on. NVIDIA doesn't actually make their own chips. Just like Apple, just like AMD, they're what's called a fabless company. They design, but they don't manufacture. So who does? Well, the reality is that almost every single one of the world's most advanced AI chips is made by one company, TSMC, the Taiwan Semiconductor Manufacturing Company. This one company has perfected the art of turning those 80 billion transistor blueprints into actual physical things. And that concentration of skill has made TSMC, you could argue, the most important company on the planet. And, as you can imagine, a huge focus of geopolitics. And what that creates is this incredible dependency. It all comes down to a really simple, powerful truth. No silicon, no AI. It's that simple. Without the physical computer chips coming out of these factories, this whole AI dream, it just stops. Okay, so this physical reality, it brings us to our last section, the real cost of all this. And I mean the real cost. We're going to zoom way out now, from the tiny world of transistors to the massive scale of global infrastructure. So the true cost of AI, it starts right here, on this tiny microscopic level. Just designing and engineering a chip with billions of transistors, that's just the first step. And it's an incredibly expensive one, on a ladder of costs that is just, well, it's staggering. Because you can't just plug these chips in anywhere. You need to house thousands of them in a special building. A single giant AI data center can cost billions of dollars to build. Billions. And then you have to turn the lights on. Just one of these data centers can suck down hundreds of megawatts of electricity. That's literally enough power for a small city. And just like that, the digital world of AI slams right into the very real, very physical limits of our power grids. So what this all means is that the future of AI, it's not just about making bigger and bigger software models. The real challenge, the next big hurdle, is physical. It's all about making more efficient chips. How can we get more performance for every watt of power we burn? So the next time you use an AI, just take a second and remember what's actually going on under the hood. It's not some abstract thing floating in the cloud. It's a physical marvel. It's powered by these specialized GPUs doing insane amounts of math. It's being fed by that super fast HBM memory, and it's all built on silicon that is pushing the absolute limits of physics. And that kind of leaves us this one last big thought. The future of AI, it feels infinite, right? Like there are no limits. But the hardware it runs on, the silicon, the electricity, the factories that build it, that stuff is very, very finite. So what happens when our infinite software dreams crash into the hard wall of physical limits? I think that's the question that's going to define the next 10 years of artificial intelligence.
Inside silicon, the technology behind everything.